Okay, so in this session we are going to see what is the dimensional modeling, okay, what are the different schemas available. Okay, so what is dimension modeling basically? Okay, so dimension modeling is a mechanism where you will arrange the databases, the tables in such a way it would be easy to understand by the business. Okay, so how business will understand what are the entities exist in the business, what are the relations in between the entities. When I say entities, it could be a customer. Okay, for any business, customer is an entity, a common entity, and the other entities would be products, the other entity would be time. So when we have all these entities which are related to business, how efficiently we can arrange them so that we can make a relationship between them and we can get some business query answers. So that is all about the dimension modeling. Okay, when I say the relation, what is the relation between the customer and the product? The customer buy a product. Okay, that is the relation. So, okay, then how many customers will buy how many products? One customer will buy one product, or one customer may buy many products, or many customers may buy one product, or many customers may buy many products. Okay, these are cardinalities where we will call it as a relation. Okay, so we'll try to have a clear understanding of all these entities, relations, cardinalities, granularities, everything on the paper. That is called as the dimension modeling. Okay, so there are two types of dimension modelings available. Okay, basically star schema and the snowflake schema. Okay, so these are the basic schemas. We have so many other schemas also, but these are the schemas. Okay, all other schemas are derived from making them hybrid or making them some tweaks of these existing schemas. So these are the basic schemas what we are going to see, star schema and snowflake schema. And before understanding these schemas, okay, basically we'll see what is a dimension first. Okay, to understand dimension modeling, we have to understand what is a dimension. So what is a dimension? It is defines a business in terms of already familiar to the users. These are dimensions are those which are already familiar to the business. And these entities, when we functionally derived it as a technical entity, these tables, so this entity becomes a table when we technically implement it. So this table will contain very wide row. That means number of columns are high. Okay, and all these columns contain the descriptive text of the entity. Okay, let's suppose, for example, customer. When we are considering customer is an entity, okay, to describe the customer, we have to have so many columns. Okay, what are columns? For example, customer number, we start with customer name, address, phone number, age, marital status, number of kids, occupation, salary, blah blah, a number of properties, okay, what we require to describe the customer. Okay, so that's where these entities, when we call them as dimensions, these entities or these tables will contain more number of columns, but small tables in the sense the number of rows. Okay, they have very less number of rows, because once the customer join, till a change happens in his information, the row would remain still. Without any changes, it will remain same. So that's where once a customer join the organization, okay, whatever the business is, it could be a bank, it could be telephone, telecommunications, insurance, whatever. Once a customer joins the business, the customer information is stored in the customer dimension with all these details, okay, with a wide row, but it is a single row till a change comes in his information. Okay. And these dimension tables are generally joined with fact tables to derive the information. We'll see that after we see what is a fact. And then typical dimensions include time periods, geographical regions, products, customers, salespersons. Okay. So these are the typical common dimensions for any of the business. Okay. And dimensions are similar set of numbers upon which the users want to base an analysis. Okay. So as a CEO, if I want to analyze my business, these are the key factors based on which I will do my analysis. Like, who is the customer making more revenue for this business, or who is the customer who is not active for last 6 months. Like this, I can fire some queries as a business user. I can fire some SQLs or some queries to see based on this particular entity how my business is performing. Okay? Or maybe if you consider product, okay, which product get me more revenue, okay? The discount on which product makes more profits for the last quarter. Like this, we can base an analysis on these dimension entities. Okay. And one more short way to understand dimension is all these dimensions are answers for all WH questions of business. Okay. Which product or which customer, or who is the vendor, who is the customer, who is the employee, okay, how he is done, is it online or is it a offline business, or is it a counter business, or where, in which location this business happened, when, is it the last quarter, is it last year, when this has happened. That describes the explanation about the facts. So all the answers what we give for business for WH questions are dimensions. Okay, so this is a tip to understand what is a dimension. Sorry. So in business questions, whatever answers we give for which, who, how, where, and when, okay, that those are based on the dimensions. Okay. And coming to the characteristics, the discretely valued descriptions of variables which are more or less constant. Okay, see, they are more constant. Okay, when I say customer, once we enter them with the customer information, we don't have any change, probably at least 3 months, like a minimum of 3 months or 10 days if we consider. Okay, maybe after 3 months or 4 months he may change his marital status, or he may change something else, address, phone number, something, but till he change we don't have any difference. We don't capture any differences. Similarly, product, once we introduce a product from the company, we'll stick to the product description, the price, everything same until unless we change the product price or product description or product name, something. So till then it will remain constant. So these values are more constant or less constant, but they are almost constant. More or less it is constant. Okay. Compared to facts, it is the statement. Okay. Fact, because fact is a transaction. Transactions are every minute or every second change, right? Or maybe new additions or maybe updates, whatever it may be. Transactions are randomly very fast. So compared to the fact tables, dimensions, we say they are more or less constant. Okay. And these dimensions enable say, the slicing and dicing options. Okay. So when you say slicing and dicing, these are the OLAP functionalities which are enabled with the help of these dimensions. What is a slicing? Slicing means the information or the question about one particular dimension. Okay, let's suppose if I ask the same question again, okay, who is the customer who caused the top revenue for this quarter, or who is the customer caused the top revenue. So when I say this question, I'm asking about the customer. Okay, I'm not asking for any other dimension, I'm not adding any other dimension, I'm just asking who is the top revenue customer. So it is the combination of the fact table and the customer, because we have to get the revenue, maximum of revenue of all the customer dimensions. Okay, so it is called a slicing. So when you query information based on a single dimension, it is called as the slicing. If I keep on adding other dimensions also in my questions, like who is the top revenue customer in last quarter, so I'm adding the time dimension, so it is called as the dicing. Okay, so first I will start with the slicing, so that I will slice means I will cut some information so that all the information from fact which are related to customer only I am interested in. Okay, I'm not interested in any other dimension. I want information from the fact but which are related to this customer. So that is the slicing. Okay, and when I add this customer information with any time dimension or product dimension, then it will be called as the dicing. So who is the customer who is getting top revenue, who is causing top revenue in last quarter? So I am combining with some other dimension, so it is called as the dicing. Okay. So like this, we'll use the dimension tables to populate. Okay, they are very wide rows, they are having very wide rows, less number of rows, more or less constant when compared to the facts. Okay, and when we can do the slicing and dicing operations, okay, by combining the information of fact with one customer, it is called as slicing. If we add it with more dimensions, it's called as the dicing. And coming to the fact tables, the fact tables are central tables. Generally in the pictures it is shown as in center because it has the relation with all the dimensions. How it builds the relation? By having foreign keys of all the dimensions within it. It can maintain all the relations, because if you see time dimension, we will have a time ID here. In sales fact, we will have a time ID here as a foreign key. So here it is a primary key, here we have a foreign key. So this fact table will have relation with all the dimensions. Just a moment. Okay. So these facts have relation with all the dimensions in terms of primary and foreign keys. And what is a fact table? So fact table is a central table which is mostly raw and numeric. That means it has almost numeric values, okay, which can be calculated. Okay. In terms of dimensions, what we have seen, we have all descriptive text like name, address, age. The age may be a number, but it is a description of the customer. Right? So all the data elements what we have derived for the customer, they are the description texts. But in fact table, whatever columns you add, they are most related to the numerics, the raw numbers. Okay, what is the revenue? What is the cost? What is the sales? What is the quantity? Okay, all such numbers are entered in the fact table. Okay. They are narrow rows. That means less number of columns, but large number of rows. Okay, the number of rows are very much huge, but the number of columns are less. Okay, and these fact tables access via dimensions. Okay. So facts are measurements that users will apply arithmetic calculations generally, like this. What is the average of the sales across all the products, or what is the total of products sold, like this. You may apply the arithmetic operations on the revenue, the sales, the quantity, whatever the columns what you add on the fact tables. So fact tables are central tables which contains numeric values, okay, which can be applied with the arithmetic operations, have very less number of columns but huge number of rows. Again, to access these fact tables we cannot directly access, we generally use the dimension tables and the relation with the dimension table to get the data. And these dimensional data models majorly fall into two types of models. Those are star schema and the snowflake schema. So why and when we choose these schemas? When do we go for a star schema? When do we go for a snowflake schema? Okay, that all depends on the presentation restrictions, okay, how efficiently the presentation should be, and how much inconsistency is there in the data, how much complex queries we are going to fire on this top of this model. All these factors may influence which schema we have to use. Okay, so once we understand the schemas, we will understand, okay, how these factors influence to take a decision which schema we have to go for. The first one is the star schema. A database design that stores a central fact table surrounded by multiple dimension tables. Well, this is a simple definition of star schema. It means, okay, whatever we have seen so far, a fact table, a single fact table is surrounded by multiple dimensions with the relations, with the foreign key primary key relation between the dimension and fact tables. Okay, that is called as star schema. Okay, so it is a combination between the fully normalized model and the denormalized model. Okay, why this statement is, when we say normalized, The table should be split into smaller tables. Okay. When I say denormalize, all the tables should be combined into one table. But star schema is a compromise between these two. That means it is distributed across facts and dimensions, so that is the normalization. But when you consider a single dimension, that could also be normalized further, but we don't do. So it is in between a complete normalization and a complete denormalization. We are not making a fact and dimension in a single table. We are doing a portion of normalization there by making fact table and dimension table separate. But within the dimensions, we can still do the normalization, but we are not doing it. Okay? Maybe because of the performance reason. Okay? If we have a third normal form applied on the dimensions, it may split onto some 10 tables, let's suppose. And if you want to get information across these 10 tables, you have to do 10 joins. So these 10 joins may be a costly operation when you consider a RDBMS. Okay? So you may not propose to normalize that dimension into 10 different tables because the cost of joining these tables will be higher when you ask a question on this particular dimension. There you may propose star schema where you have a single dimension but it is joined with the only fact table. So descriptive dimension information is maintained in a set of denormalized dimension tables. Okay, so the dimension tables are maintained in denormalized model tables. That means they are not splitted into smaller tables, but it is maintained as a single table. Okay. So this is the star schema proposed, and this is a Irving diagram, the real-time Irving diagram, which shows a star schema model. We have a fact table, we have the dimensions surrounding, and these are primary keys in each dimension. In branch it is branch key, in customer it is customer key. And when we have a relation with the fact table, all these keys in all the dimensions will become foreign keys. Okay, so combinedly, all these foreign keys, it will become a primary key. Okay, so in Irving, when you have an entity represented in a box, okay, the top box, okay, the primary key box, okay, this is the primary key portion. Okay, so in this time dimension, time key is the primary key, product key. But here, if you consider sales fact, what is the primary key? The combination of all. The time key, customer key, product key, branch key. Each individually it is a foreign key, but combined it is a primary key. And it adds all the numerics, revenue, quantity, cost, and margin. And if you see facts, if you see dimensions, these are the descriptions. Okay, we don't apply average, okay, sum, total, all these functions to the dimension, but we apply on only the facts. So this is a typical dimension modeling. So with this model, I can answer many of the business questions, right? So who is the customer who bought this product in so and so time? Can I make that query happen? Yes. Customer is joining with sales fact, so only I will get the customers. And then who bought this product? So product again will be joined with product dimension and get all the product information. And then the sales fact will be joined with the time. Okay, so which time you want to analyze with the time key, and you'll get the information. Okay, so with this star schema, we can get our business queries answered very easy. And coming to the snowflake, it is a database design that stores a central fact table surrounded by multiple dimension tables decomposed or normalized into one or more hierarchies. Okay, so here it is almost same to the star schema, but here the difference is the dimension tables are not be as a denormalized tables, but they are splitted into, or they are normalized into some smaller tables. Okay, so when we choose the snowflake schema, when the data in the dimensions are so huge, okay, holding the data in a single table is costly. Okay, so when we want some information, we want to fetch all this table into the spools or the RAMs. Okay, so in such cases, again, it is better to split it into two tables, and whenever we need the information, we will join the tables. So in some situations where the data is very huge and the changes in the dimensions are also very huge, we may propose this snowflake scheme, in which at least one of the dimension is normalized. Okay, it is a star schema in which at least one dimension is normalized. Okay, that is called as a snowflake scheme. Okay. So most probably the lookup tables, okay, the smaller joint tables are will become the snowflakes. You see, time, customer, product, okay, they are okay. But here, when I'm coming to region, I split it into city and region. Both are related to the location dimension or region dimension, but they are split, the city and region. Okay, and one more reason why we'll go for snowflakes are to do the roll-ups. When I say roll-up, first I will calculate the sales for each city level, and some cities, a group of cities will become a region. So when I want to know the sales for a particular region, then I want to get the sales for that group of cities. Okay, so if there are some reports which are based on the roll-ups, okay, the organizational hierarchies, okay, first I wanted to find the lowest level of sales, maybe if you consider a bank centers. Okay, some group of centers in that particular region would become the region sales. Okay, and group of regions in a particular market are called as market sales. And a group of markets which are existing in a franchise are called as the franchise sales. Just like that, we may divide our business into a smaller chunks so that we can directly roll up to the higher levels and get the status. Okay, so if we have such a requirement of rolling ups, okay, most probably all the business would have this rolling ups also. Okay, so in such case, we may divide our dimension into smaller tables to do the roll ups. Okay, these are called as snowflake schemas. Okay, so this is one of the real-time snowflake where the product dimension, okay, it used to have all the columns within this, but it got normalized now and it's split into several tables with the relation. Product, package size, okay, based on package size it may different. Okay, based on brand of the product, based on the category like departmental or it's non-departmental. I was coming to here, storage type, shelf life dimension. Okay, so based on several factors, you may do a roll-ups on the products. So you may split the table. Okay, when I say split, it is normalization. When you do normalization of the dimension and when you split into smaller tables, it would become a snowflake scheme automatically. Okay. So most dimensions change over time. Right. So products, when we introduce a product to the market, they will be introduced with certain information. Let me see one question here. Yeah, please go ahead. Let me unmute.
Yes, so what is a lookup table then? And the slide you showed me previously. Yes. One slide back more. In there it says second paragraph is a snowflake table in parentheses lookup table. So like what is the lookup table here then?
So lookup table, see, if you have cities, the city names may be repeated in the dimension table. Okay, let's suppose my business is across 3 cities. Again, I have some 1 million customers across only these 3 cities. Okay, so instead of storing the city name for each and every dimension row with this city name, city name maybe I define it as a varchar of 20, let's suppose. So it may occupy 5 bytes or 10 bytes whenever I store the city information. Instead of this, okay, you may come up with a lookup table. Okay, so maybe in along with city, you may want to see the information to which region it belongs to which country it belongs to which market it belongs to. So all this information also you want to store along in the dimension. Okay, within the dimension, then you have derived some 4 columns in the dimension of location with all this information like city name, the region in which it belongs to, the market in which it belongs to and the franchise in which it belongs to. So instead of this, what we can do, we can normalize this information. Normalize means all this related information, the city related information. You can make it in a separate table and you add a number, the city number there. Okay? And instead of storing all these 4 columns in the region dimension, you store only the location number. Okay, so you will do all your joins and all your populations. And now if you want to know in which region the sales is more, then what you do, okay, you will consider all these city numbers which are belonging to the same region. Yeah, how do you do that? You do a lookup with the city code information, city code lookup, let's suppose. Okay, so which gives you the city number by getting a city name. So here in the normal dimension, you have stored the city numbers, but you don't know city names or in which regions they are belonging to and all. All this information is stored in your lookup table. So what you do, you will join it, the city number of the dimension with the lookup table and get which city's information you are asking for and which region the city belongs to and everything. So what we are doing here, the normalization, but the normalized small table which holds the static information of each city and city name in which region it belongs to, that is called as a lookup table.
So lookup is actually basically dimension table. You just
Yes.
give a name. You're just looking the more specific value or information.
Yes, we generally call it as static information.
Okay.
So once this is built at the business level, what all cities we are belonging to and what is the numbers we have to give, that is static.
Okay.
Almost. So these city numbers will be having in different rows of the dimension table whenever you are inserting it. But the static information will still stay there. So we may call it as lookup tables, static tables, okay, or basically it is a dimension only, which is helping us to get more description of the dimension.
Okay. All right. Okay.
Any other questions?
No, I'm fine. I'm fine. Thank you.
Okay. Okay. So now we're going to see how we maintain these dimensions. Okay, because when we consider fact tables are always the addition of the transactions. Right? So when we purchase one product, who purchased it, what he purchased, at what time he purchased, with what cost he purchased, what is the profit out of this transaction, everything is an addition. Almost fact tables are not updates. It is always addition. That means inserts for the fact table. Right? But coming to the dimension table, we have changes. Once we added a customer in our customer dimension, it is not that we will add the same customer whenever a change happens to you. Right? We have to do some certain process so that we can identify it is a change in this same customer, but it is not a new addition. Okay? So there is no such a problem in fact table. Whatever happens, it is all a new addition, so new insert. But coming to dimensions, we have to carefully maintain them whenever there is a change in the dimension information. Okay, let's suppose if you consider a product, I have introduced the product. So after some time, I have to change the price of the product. So shall I insert a new row in the dimension, the product dimension with the new price? If I do that, finally I will lose my grip on the control. I will lose my control on my dimension. So if I wanted to find how many products I will have duplicated rows based on different changes in the attributes. So I cannot find how many products totally I have in my organization. Okay, so to understand this, we use that same sheet to use in our case study basically. Okay, so this is. So here, this is my dimension. So when I entered my dimension information of a customer with the name, some name, I have entered, and he started his business within our organization on some date. Okay. So now, after some time, he reported a phone number change. So shall I insert a new row for him? Okay. If I insert the same row for him but with the different information on so only the difference is in phone number. He reported a change in phone number. I have inserted one more row for him to represent this one. So I cannot do this because now I am having the same customer 2 times as duplicated. Okay, shall I update the phone number which is already existing? Okay, I can do that. Let me do that, and I don't enter a new phone number. Okay, so this is what happened. Okay. And after some time he changed an address, so I have updated the address. Maybe it is a city. Let's suppose it is city name. So he was in Kansas City initially, and when he reported his change of city to New York, okay, I'm not going to insert a new row because it will duplicate the same customer information. So I'm not inserting a new row, but I'm updating the existing row with the new city. Okay, so now after some time as a business CEO, I wanted to see what is the revenue this particular customer generated when he stayed in the Kansas City. So I have all the facts available in the fact table, but in dimensions I have changed his city to New York. Now I don't know at some point of time he worked in Kansas City because I have updated his information in the same row. So now if the business asked us, yeah, I know he stayed in Kansas also sometime before, can you tell me what the revenue he made in Kansas? So can business answer this question now? Because they lost that information that they stayed in Kansas. So if we update, okay, for some reasons, if you update the existing dimension with the new information, you will lose the track of history, right? So if in your business, for few of the columns, if you don't want to track the history, then you will update it. Okay, this is also one type of maintenance where you may not track the whole history, but you want to know the updated information only because you are not interested in the tracking history based on this particular column. So here in this city, yes, I want to track the history, so I should not do update. But maybe like some other columns are there, okay, the number of children or something, which you are not interested in. As per my business, I'm not interested in number of children what he has. So if he report any change, just it is enough for me to know the updated information, but I don't want to track his history. So in such case, in that particular attribute, you may maintain this update. So first he has 2 kids, now he has 3 kids. Just I will update the 2 with the 3 so that I will know update information. So this is also one type of maintenance of the dimension. This is called as the type 1. Okay, this is SCD type 1, slowly changing dimension type 1. Okay, so here whenever the change comes, we don't want to track history, we want only the updated information. And if you want to track history, then what we need to do? Okay, so he is with Kansas, so let us consider this. Okay, so here this city, this Kansas. For example, if you don't have these, yeah. So this is the information what I generally maintain in my dimension: name, number, address, city, phone number, and marital status. After some time, he reported change in this city. I wanted to track his history based on the city column. I don't want to lose this history. Then how I can maintain? I can maintain in such a way with the customer name, number, city. Now it is New Year. Because I don't want to lose the history, so I maintain like this. So just see up to here. And this is our table. As I wanted to maintain history, I just inserted one more new row with the same information but a different city information. So I have tracked the history because one row is there with Kansas, one row is with New York. But if my business question is, what is the last quarter revenue generated by this customer? Okay, so only last quarter revenue I want now. So how I would know which is the current location for this customer, so that I can try to join with this New York location region and get the information. Okay, because I should know New York is his current location, then only I can join it with the New York City's region ID and then get the revenue from the fact table. But how I can know this New York is his current city and his Kansas is the old city? Because I didn't maintain any information which indicates me which is its current location. Okay. Let's suppose he changed his phone number maybe, and I wanted to know, okay, along with his phone number, how many transactions he made. Okay, if we made a number change also, let's suppose. Okay, I wanted to find along with this phone number how many products he purchased online with this contact number. Can I know that? Which phone number is current? I don't have any information. Okay, so to enable to understand which row is active currently, you have to add some audit columns. Okay, when I say audit columns, these are some columns which are having not the business information, but they are used to understand what is the updated business, what is an active row in the dimension. Okay, those are called as the start date and end date. Start date and the end date. Okay, if I maintain the start date and end date also along with the dimension in such a way, when he added, the start date is the day on which he joined the business and the end date would look like this: a high watermark record or high watermark date which won't be reached in very soon future, 12/31/999. So this is the date most of the organizations use to represent a row as an active row. So end date. Okay. So they will add these two columns to each and every dimensions whenever there is a need of tracking the complete history of the dimension. Okay. So that whenever the customer added, you will be added with the current date as business date or start date and end date as a high watermark date called 12/31/999. Okay, it's fine now. So this is the active record. Whatever analysis you want to do on this customer, current information is get from this current row where end date equal to 12/31/999. Okay, so after some time when he changed his city to New York, what I'll do, I will insert a new row, and before inserting I will update his end date with the current date when he reported the business change. So let's suppose it is after almost a month, 10/10/2010, he reported a change in his city. So I will update the previous record's end date with the 10/10/2010, and I will add a new row with the new city name, and the start date would become 10/10/2010 for now, right? And this would become 12/31/999. Okay, so consider only these two rows. Remove this. So when you consider these two rows, this is the initial row which was inserted with start date as the business date when he joined and end date which 12/31/999. But when we reported a change in city, we inserted a row. The start date is the date on which day he reported, and before inserting it we generally do an update on the end date of the previous record so that it will reflect the same business date here. So these two rows are same, and we'll insert the new record with the end date as 12/31/999, the high watermark date. So with this I will get to know which is the latest row with the latest information of this customer and which is the historical information of his customer. What is the change in these two? The city. So this city is active between these dates, and after this date this is the active record. Now if the business asks me what is the revenue he generated when he stayed in Kansas, can I answer that? Yes, because I can get Kansas City and between what dates he stayed in Kansas, and I will use this information to join with the time dimension. Okay, so it is a 2009 third quarter or fourth quarter, then I will join it with the time ID in the time dimension and get the information so that I can answer the question, when he was in Kansas he has spent this much of revenue. Okay, he generated this much of revenue on such so and so product, because I have the tracking of his history. Okay, so after some time if we reported one more city change, what are the other cities? New York, San Diego or something. Maybe spelling mistake. Okay. So he may change his city to San Diego. Then what we do? We'll insert a new row with current business date as 11/11/2011, and the same date will be used to update the previous record's end date, and we will insert the new record with the 12/31/99. Okay, so along with the old records we'll keep the new records also, but we'll maintain history with the help of these two audit columns, start date and end date. So if there is one more change in any of the columns where they wanted to interest to capture the history, then we use again the start date and end date, okay, to update the existing records end date and to insert a new record with the new business date and high watermark date as end date. So when you track the complete history of the dimension table with the help of these audit columns, it is called as a type 2, SCD type 2. And there is one more mechanism also called as flag mechanism. So along with the start date they use a flag. Okay, instead of end date, or maybe along with the end dates they may use a flag whenever there is one more record for this customer inserted. Okay, they update the flag with the zeros. Okay, so initially we'll start with 1 to represent it is in the active record, and whenever a new record is inserted for the same customer with a change, then the previous record's flag would become 0 and the current record would become 1. Okay, and when we have one more record, the previous record's flag would become 0 and it will become a 1. Okay, so with the flag mechanism also you may maintain the history. So there are two mechanisms in SCD type 2. Okay, so sometimes they may ask you what type of dimensions you maintain. We'll say SCD type 2. Okay, so they will ask you, okay, how do you maintain SCD type 2? Okay, you may explain the start dates and end dates, or you may explain with start date and flags. Okay, there are two types of maintenance of dimension history. Okay, within type 2 we have the date mechanism and the flag mechanism. Okay, and what all operations we generally do to maintain this type 2? The update operation, where we have to update the end date, and the insert operation. Okay, so these are the two operations, two SQLs required to maintain the type 2. And how about type 1? Type 1 is no history. No history is required. When no history is required, what is the operation we need? It is only update always. Okay, so for maintenance of type 1, okay, to maintain type 1 we need only one SQL operation called updates. To maintain type 2 we need two operations for each and every row. Whenever a new change comes in, that is an update and insert. And now we'll see the other type called 3. What is the type 3? It is hybrid between these two. Why we say hybrid between these two? In type 1 we don't maintain any history. In type 2 we maintain complete history. Okay, how many cities he go, but we'll track them. Maybe 10 cities, 20 cities, 30 cities. We'll maintain complete history here. But here in type 1 we don't maintain. Okay, we are not bothered about the number of cities. We just require the current city. Okay, the latest city will maintain here. We don't track the history. That is type 1. This is type 2. Complete history maintenance. What is the type 3? It is hybrid in between these two. It means we maintain history, but we don't maintain the complete history. Okay, we maintain a limited number of versions of history. That means I'm interested in only previous city and the current city, but I don't want to track each and every city. At any particular time I want to know the current city and the previous city, or maybe like this. Okay, the phone numbers, I wanted to know only 3 phone numbers at any point of time. That means current phone number, previous, and previous to previous. So I'm okay even I have only 3 versions of history, or 2 versions of history, or 5 versions of history. So as a business I may define, okay, I'm dependent on only the 5 versions of history. So I'm limiting my history capabilities here. I don't want to track the n number of histories. I just interested in 5 limited history versions of a particular dimension. If I limit the number of versions I want to maintain in my dimension, it is called as a type 3. So how we'll maintain a type 3? We will ask the business user how many versions of truth you want. Then let's suppose here he says I wanted to maintain 2 versions of a phone number. Then we will maintain 2 columns for the phone number like this. The current phone number and the previous phone number. Let's suppose if he says I wanted to maintain 3 versions of the phone number, then what we do? Current phone number, previous one phone number, or if we want one more history, previous 2 phone number, previous 3 phone number. So whatever column, okay, which makes you understand this is the second history, third history, fourth history. So when we have this information added the first time, what happens? First time the customer added, the previous phone number is null because he is currently joining now. So his current phone number will exist, pre-phone number would be null. Okay. And you maintain or don't maintain because the start date and last update date. Here it is not an end date. If you observe, last update date. So this record is always active. So there is no indication required that this particular record is active or not. This record is always active, but you may know when it got last updated. So let's suppose for the first time, this is the situation, right? So when the customer joined this organization first time as a customer, so his all information would look like this. Yeah? Pre-phone number is null, current phone number we know as of now, and the start date is 99, and the last update date of this record is also 999. And after some time, when he reported the phone number change, what we do? We'll do an update operation such a way that this current phone number will become the pre-phone number, and current phone number we will update with the current changed phone number, and then the last update date will be changed to the date at what date he reported his change. Okay. So I have the history maintained here, the 2 versions of history I maintain, and I know Okay, at what time he has reported his change. Okay, now if he has one more change, then what we'll do? We'll do one update here so that the current will become a pre-phone number and a new phone number will come here. And then again the last update date. Suppose this is the date when he reported the last update. So this is the way we maintain the type 3. So at any point of time, I know two versions of his history, the current and the previous. If you want three versions, you add one more column so that two updates should happen. So pre-phone number will be pre-one phone number, and then current will be pre-phone number, and the current phone number will be the new number which he reported. Like this, based on the number of histories, the number of versions you require, you will do those many number of updates. Okay, and plus one to update the last update date. Okay, so this is how we maintain type 3, which is the limited history maintenance. Okay, so to maintain the type 3, we need two updates. To maintain type 2, one update and one insert. Okay, to maintain type 1, it is one update. So these are the operations we do and how we do, okay, with the audit column, what type of audit columns we require in each type, and what is the purpose of using type 1, type 2 and type 3. Any questions here? The types of dimension and slowly changing my dimensions.
No, just one question. So in SCD, the update will always happen first and then insert, right?
I mean, it could be. I mean, yes, logically the update should be first and then only the insert. But even in the batch operations, you may insert all the records, and whenever the start date is less than the current record start date, then update the end date with the current date. That also can be. But it is not mandatory that the update should be done first. You may logically do any way, but yes, I mean, you can do, I mean, it is best practice. You can update the current record and then insert it. It is easy, but it's not mandatory.
Okay.
So let's see. The type 1 overview is, here we don't want any history. It is only the update statement required when you don't want any history. Right? So whenever he reported a change, you just update that particular column. So there are no audit columns required in this dimension. So this is the customer dimension. If we don't want to track any history, the dimension would look like this. All first name, last name, matter status, age, education, street, city, state, account number. There are no audit columns if you observe. Okay. So if you want to track the history and the complete history, then you will go for type 2, and when you are designing your dimension with the type 2, you have to add the additional columns. See here at the end of the dimension, last update timestamp and the active row indicator. Okay, this is a flag mechanism they are using. Okay, most probably, okay, whatever projects I see, okay, I see the date mechanism, start date and end date. Yeah, but sometimes you may see the dimension which maintains type 2 with the flag mechanism, that is row indicator. Okay, so last update timestamp will keep on change, and an active row indicator which represents 0 or 1, okay, or maybe A or B, something. Well, some code will indicate this particular record is active, this particular record is not active. Yeah, generally they use a byte integer, a single byte integer, a single bit integer, 0 or 1 to represent if the particular record is active or history. So these are the two columns you will observe in type 2. Okay, what all operation we do? One insert and one update. And coming to type 3, we maintain limited history. So by seeing this dimension, can you observe on what columns I am maintaining history and how many versions of history I want to maintain? Can you tell that by seeing this dimension? Just read out these columns and tell me on what column I am maintaining history and how many versions.
It's only one version.
Okay. On what column?
Customer name.
Only one column, two columns. Okay. So current first name, current last name, original first name and original last name. So initially these original names will be null and the current names will populate with the proper values. And when he reported his change in his name, then we'll update the originals with the current, and in current we'll update the new names. So two versions of name we are maintaining. Okay, history of one version, but totally two versions of name we are maintaining on the name fields, the first name and last name fields. Okay, and you will maintain a last update timestamp to identify what is the date the last update happened. And what SQLs we require? These all update statements based on the number of versions, number of truths you want to maintain, those many number of updates we do on the dimensions. Okay, so now we'll see one other type of dimension called degenerated dimension. What is a degenerated dimension? It is a dimension, but if I maintain this field in dimension, I need to do a rapid changes to the dimensions. Okay, if I maintain this dimension in a fact table, it won't make any sense. Okay, there are some attributes in the dimension modeling. If I keep those attributes in the dimension table, it will cause me to rapidly change the dimension information, because we know dimension information should be consistent for at least, when compared to fact tables, the dimension table information should be consistent. Okay, it should be slowly changing, but it should not be like for every minute we change the dimension. Do we change the address every minute? Do we change the phone number every minute? So comparatively, okay, with the fact, the dimension should be consistent or constant. If there are changes, they have to make changes slowly in the dimensions. But if I put some attributes, it may cause my dimension table to be changed very frequently, like every minute or every second. So if I keep the attributes in a fact table, that won't make much sense. For example, the order number or invoice number, the bill of landing number. So these some numbers, these are numbers in terms of the data types. Okay, but they don't do any measures, right? I cannot apply average function, or I cannot apply the sum function on the order numbers. Does it make any sense? By applying average on the order number or invoice number, it is a dimension kind of attribute, which is a description, so on which we don't apply the numerics. So this is the property of dimension. So if I keep this order number or invoice number in any of the dimension, like product or customer who purchased this invoice. Invoice means what? The order, okay, the receipt number maybe, okay, the invoice number, the work order numbers, okay, whatever numbers generated due to this transaction. If I keep this number also along with the customer dimension, what happens? Whenever the customer does a transaction, a new invoice number is generated, and to maintain this new invoice number, I have to track the complete history of this particular customer. Right? I may have to insert a new record and update the last record with the current business date, the last record's end date with the current business date, and insert a new record with the 12/31/999 as an end date. So whenever the customer does a transaction, I have to keep on adding the history for this record. So is it reasonable to add the invoice number in the customer dimension or any product dimension or any of the dimensions? No. But is it used to do any calculations, arithmetic calculations, like sum of the order numbers or average of phone numbers or average of order numbers, something? No, it is not a fact also. Okay, but it may be reasonable if I put it in fact table, because of reducing the number of records added in the dimension table. Okay, so these are some attributes which are not suitable for the facts, but they exist in the fact table. Okay, these are called as the degenerated dimensions, possibly degenerated dimension attributes. Okay, so these types of fields which are more descriptive type, but they are not able to incorporate it in dimension tables. They are placed in facts, but they are not actual facts. Okay, these are called as the degenerated dimensions. So including these fields on the fact tables amounts to denormalizing the attribute due to the granularity of the fact tables, being the document itself or a line item of the document. So this is a document number. So document numbers, if you maintain dimensions, it will keep on changing it. So you may add it in the fact tables, but they are not actual facts. So the such type of dimensions are called degenerated dimensions. Okay. And coming to the facts also, we have several types. You have the additive facts, non-additive facts, and semi-additive facts. In terms of facts, we have three types of facts. So based on the situations, okay, on which we can do a complete sum up based on the all dimensions. It may change into any of these three attributes. Maybe additive, maybe non-additive, maybe semi-additive. We'll see that. Additive fact. What is an additive fact? Measurements in a fact table that can be added across all the dimensions. If there is a fact item, that is a measurable item, which can be applied with a sum function across all the dimensions, that particular fact is called an additive fact. Okay, for example, the revenue, the cost, the quantity. If you consider these type of facts, the revenue, cost, I can add a sum function. I can apply a sum function on the revenue based on any of the dimension. Such a way, the sum of the revenue, the total revenue generated by this customer. Can I do that? Can I do that analysis of finding the total revenue generated by a customer? Or can I do the total revenue generated through the product? Can I do that? Yes. Or what is the revenue generated, the total revenue generated in fourth quarter of 2011? Can I do that? Yes, I can do that. Because I am applying total on the revenue based on the time dimension, based on the customer dimension, based on the product dimension, based on the location, maybe. What is the total revenue generated in the New York? Can I do that? So based on location, I am doing a additive function, the sum function on the revenue. So this revenue, cost, and quantity can be sum up based on any of the dimension. So these facts are called as additive facts. And the next type is called as semi-additive fact. The measurement in a fact table that can be added across some of the dimensions but not others. If we can keep on adding the facts based on few dimensions but not all, those are called as semi-additive facts. For example, current balance. Okay, in my account I have a current balance. If I add the current balance as per a customer, does it make any sense? Okay. See, current balance is a semi-additive fact as it makes sense to add them up for all accounts. Okay, if I add the current balance of all the accounts of that particular branch, I will get current balance of that particular branch on that day. Okay. But if I add current balance of the same customer over a period, that means time dimension. If I add the current balance of the customer over a period that with the along with the time dimension. Do I make any sense? So yesterday I have 100 rupees balance and today I have 200 rupees balance, okay, outstanding balance or current balance. If I add these two, am I going to derive anything? No, right? So as per the time dimension, if you add the current balance, you are not going to get anything. But as per the customer dimension, that means all the customers current balance, you are adding it, then what you are going to derive? You are going to derive the current balance of the total branch or total bank. Okay, so the current balance is a fact which can be added across only the customer dimension but not the time dimension. Okay, so there are some facts which can be added or which can be applied with the sum function with few dimensions but not with other dimensions. Those are called as semi-additive facts. And the other type is non-additive facts. What is a non-additive? As its name indicates, we cannot be apply the sum function on this fact with respect to any of the dimensions. You cannot do a sum. Okay, what are those examples? Again, the same thing, order number, which is a degenerated dimension, but it is added in the fact table. Can we do any of the functions on this order numbers? Can we do any average, any variance, any of the arithmetic functions on these order numbers? Are we going to derive anything? But still they exist in fact table because they are degenerated dimensions. If we add these attributes in the dimensions, it will degenerate the rows unnecessarily. That's where we placed it in fact table. So as they're placed in fact table, they are not facts, so we cannot do any operation on these facts and we cannot sum it up based on any of the dimensions. Those are called as non-additive facts. Okay. So these are three types of facts: additive, semi-additive and non-additive facts. Any questions here? The degenerated dimension or the facts types, the slowly changing dimension models. What is the dimension, what is the fact, and what is the dimension?
Can you repeat again the
Non-additive?
Yeah, can you repeat again non-additive facts? Like, yeah, that's.
So non-additive fact, if we consider any of the order number which exists in the fact table, can we apply the sum function on the order numbers as per any of the dimension? Are you going to derive any useful information by applying sum function on the order number or invoice number or receipt number? Something is there in my fact table. Can I sum up all the order numbers and derive any fruitful information? No, right? So those type of attributes in the fact table are called as non-additive facts. You understood the semi-additive, right?
Yes.
Okay, so current balance, at least I can add based on the customer dimension but not on the time dimension. But if you consider an order number, can you do it sum based on any of the dimension? Okay, so if I sum the order numbers of a particular customer, am I going to derive anything? Or
No.
a particular period of time, if I want to sum up all the order numbers, am I going to get any fruitful result? Okay, so any dimension, you cannot derive the sum of this particular order number or receipt number or invoice number, work order numbers. So all these numbers, but they are based on facts because we cannot keep it in dimension. Why? Because it degenerates every time whenever a new invoice derived by this customer or by the product or by the time or by regions. So we place it in facts, but we cannot do any operation. Those are called as non-additive facts. Okay. And this is the last topic. Okay, so this is to give an understanding. If you have to work on a project from scratch, what are the general ideas? What are the approach we follow to build a data warehouse from scratch? First step to build a data warehouse is choose the grain of each fact table. What is the grain? Grain or granularity. What we do, we'll see what is the low level information the business is interested in to analyze. Sometimes if you consider a Walmart, if you consider a FMCG domain, as a CEO, I may not be interested in daily sales. Okay, I may be interested in monthly sales of a particular region or a monthly sales of a particular product. Okay, so this is my constraint, that I don't do a every daily wise operation or a weekly wise operation, but I wanted to see only the monthly operation. If no other business user also wanted to see the weekly information, is there any sense that I maintain my data on weekly basis, on daily basis? So every month basis I will ask all my source systems, okay, every month you send me one row which specifies your sales. So I will insert it to my data warehousing table. So whenever the customer reports or customer queries on the report on monthly basis, I am able to report the data whatever he requires. Okay, so this is the granularity which we have to first analyze, okay, what level of information they are interested in. Okay, most of the business now they are coming to daily levels, or sometimes they are asking for hourly basis also, because the real time and active data warehousing is coming into picture. They are asking for each and every minute granularity what we can maintain in data warehouse, because in early 1990s and 80s the space is very much costly. Okay, so they may compromise on the granularity of the data what they have to maintain in the data warehouse. Okay, they may ask you only weekly based data is enough for me so that I can manage it. But now when space is coming use and when processing is coming use with the advanced technologies, every business user wanted to go and maintain each granular of information so that they can go further in deep the details and can take the business. Okay? Let's suppose monthly sales of last month is 100 billion, 1 million. Let's suppose the last month revenue is 1 million and this month revenue is 0.25 million, let's suppose. So almost 75 millions got decreased. So how I can analyze this? To analyze this, what information I need is for this month, which week we have a less revenue. Maybe first 3 weeks it is almost same as the previous month weeks, but in last week only we had some earthquake or some cyclone. That's where we drastically decreased our revenue. So how will get this fact reflected in our reports? If I do my analysis from monthly to weekly, that means roll down, then only I will get to know that information. If I don't maintain that information at all in my data warehouse, is there any way that he can know that fact? No. If he wanted to roll down, then if he sees only the 4th week is a great hit in the sales, then he will try to analyze, okay, what happened in the last week? Then he will get to know, okay, something happened. That is the reason why we hit with this. If nothing happened but you still had this, then you will do analysis, okay, why it happened. Okay, you may go further. Okay, let us see what all regions are impacting this. Is it eastern, is it central, is it western? So all these region level analysis also will start. Again, you will see, okay, all regions are okay, but only EST is problem. Okay, in EST, what all cities are existing? So all cities are okay, but one city is having a problem. Okay, you will try to pinpoint. Okay, you will roll down further and further, and you will try to pinpoint where the exact problem is. Then you will take an action. Okay, so like this. Okay, earlier they don't want to maintain the whole granularity, but now, okay, for each dimensions they may ask you to maintain each possible level, each possible low level granularity. So this is the first step. Whenever you are supposed to build a data warehouse, the first question what you need to ask the business user is, what level of granularity you want to maintain the warehouse. Okay, you want to get the daily level. Okay, when you consider a time dimension, what level you want. Okay, when you consider a product dimension, what level. When you consider region level, what level you want. So this is the first question we have to get the answer. And then once the granularity is done, then you will work on the dimensions. Okay? what all dimensions we need for reporting this, and what all attributes of each dimension are required. Okay, for any business, the customer, product, time, region are common dimensions. What else you want to add? Okay, for automobile, it could be the third party vendor who supplies the raw product. It is specific dimension. Okay, the vendor dimension. If it is any other business like hotel, then it is again some other new dimensions will come up. The vendors or some other business entities, what they involve. Okay, so we have to identify what all dimensions required to enable the business users to query them. And once you identify those entities as dimensions, what attributes you have to maintain in them. That is also you have to identify. And then identify dimensional hierarchies. The hierarchies is to see what levels, okay, what levels of roll-ups and roll-downs you wanted to try. If you produce a report on sales, then you may click on a particular record which is monthly aggregated, and you may go into the weekly wise, and then within weekly you wanted to go inside the region levels. Okay, so what all hierarchies we will do, so that we will normalize those dimensions and keep it as the snowflake schemas. So whatever roll-ups, roll-downs you wanted to do, you will maintain them in normalized dimension models, so that we can do the roll-ups and roll-downs very easy. And then choose the dimensions that apply to each fact table. It is to identify the relation between the dimension with the fact tables. So what is the key in the dimension table? Can we maintain this key as a foreign key in the fact tables or not? So typically the relationship between the dimensions and facts are managed in this step. And then choose the measured facts, including pre-calculated facts. So this is to identify if the most frequent reports are aggregated reports or not. Then most of the times the business users, okay, even they wanted us to maintain an aggregated information. They wanted us to maintain the low-level granular information, but the base reports they wanted to see is the aggregated reports. First, they will start with the aggregated reports, and then they may analyze each low-level granulars. Okay, so to initially report the aggregated values, okay, you may derive a aggregated data model first. So you maintain your normal data warehouse, and when you see most of the reports are based on aggregations, then you will generate one more model which is called as an aggregated model. Okay, so each aggregated and derived fact will need to be evaluated for inclusion in the model or calculation in the applications. Okay, so we'll see, is it better to pre-calculate the values and keep it in aggregated data warehouse, so that we don't do these operations every time when they ask for the aggregated reports. If there is any possibility that we can maintain an aggregated data warehouse, okay, we will try to place them to reduce the calculations what are required whenever they file. Because if you maintain the low level granular information in our data warehouse, because every day information you are maintaining, but initially you have to report the monthly level or the weekly level information. So would it be better if I pre-calculate the values for each month and keep it in a separate warehouse called aggregate data warehouse, so that the reports would start picking up the data from the aggregated warehouse, and when they do the analysis at the low level granularities, then they will go to the normal warehouse and get the detailed data. Yes, so we will do a calculation. When you do an analysis, is a pre-calculated facts is useful for this model or not, so that the optimization in the reports would happen. If you don't do this aggregation at the data warehouse level, the reporting tools has to do these aggregations, which is a very costly operation again. So to optimize the report generation time, They will identify whether the aggregated pre-calculated facts, maintenance of the pre-calculated facts would get benefit in terms of performance or not. And then finally determine the slowly changing dimensions. How they wanted to maintain the dimensions, whether they wanted to track history of all the columns, or on what column they wanted to maintain the complete history, on what column they wanted to maintain the type 3, the limited history. Okay, you will ask questions to the business users to identify what type of history tracking you wanted to maintain. Generally, if they are not able to answer, we default take dimension 2, okay, the CD type 2. If they are familiar that this particular history is not required, then we'll take an assumption clarification from the business user and we maintain a type 3. But generally, because it is a costly operation again to convert a dimension from type 3 to type 2 or type 2 to type 3 anyway, because it is a complete model change. Okay, we have to drop the columns, we have to add the columns, again we have to populate those columns. It is a big enhancement. So in order to not to take risk, you may maintain type 2 in always the real time. If you almost clear, I mean, if you 100% clear of any column that we are not going to track history even in future, then you will go for a type 3 or type 1. But generally, in order to not to take risk, we maintain type 2 for all the columns in the dimensions. Okay, so if you clarify some questions with the business users that they are not going to track this particular history anytime, then you can confidently go for type 3 or type 1 maintenance. Okay, so these are the steps involved, are the questions, are the base steps which are required to work with business users and come up with answers, and then you prepare your high level model, the high level design documents with all the details. Okay, what are the facts required, what are the dimensions, what are the relations, what are the types, the type of dimensions required, how we are maintaining the slowly changing dimension. All these details will come up with in a high level documents. We'll get it reviewed by the customers, the users, the developers, the testers, okay, everyone in this, I mean, who are called as stakeholders for this project. And after get the approval on this high level design, we'll start the low level design along with the lead developers. Okay, this is the way how it goes. Any questions? Yeah. Okay. Good. Okay. So thank you very much.